the extra credit challenge. We're trying to find the value of theta in degrees between 0 and 360, and it has to satisfy this equation. Equations can be approached different ways. We can try to use trigonometric IDs. We'll do that next time. We can use inverses. We can take the cosine inverse of both sides, but let's not do that for now. Let's try this problem more logically with the help of the unit circle. So consider this equation. We don't like how there's a 2 right there. I like when it's just theta, not 2. So let's make a u substitution. So why don't we declare that u equal to theta and rewrite the original in terms of u. So that cosine of u equals 1/2. So yes, we're trying to find theta, but at the moment we're trying to find u. Okay, now cosine of u, based on the relationships that we've been using, cosine of u can be replaced by x, right? Now this is just a fact. This fact will tell you the value of u, and once you know u, you can find theta. Really quick comment. Let's look at this statement here. If u equals 2 theta, would you agree with me that this means that u over 2 equals theta? If I just divide the 2 underneath the u, okay? So let's just leave that alone for now. Let's continue here. Unit circle. Where do you see x being 1/2? By observation, x is 1/2 here and also here. So we're playing with 60 degrees and 300 degrees. 60 and 300 would be the values of u. So 60, and 300. So this revealed the values of u. Now that you know u, plug them in here to find theta. So let's take 60 and drop it in right there. So that would be 60 over 2 equals theta. Drop in 300 right there as well. 300 over 2 equals theta. So this is what? Theta equals 30 degrees, and theta equals 150. Now you're saying, Mr. Lee, I did that, Mr. Lee, and you said we were wrong. I didn't say you were wrong. I said you weren't finished. Because here's the deal. These are correct, but there are more solutions. Watch. Let's go back here, okay? Let's go back here. Notice what happens. As soon as you find a value for u, you're going to put it right there, and you're going to chop it in half, and that'll be the value of theta. So, over here, if u equals 60, let's go co-terminal. Let's add 360 to this. If I add 360 to this, that would also say that u equals, was that 420? Now, let's add 360 to this, so that u equals 660. So what I'm saying to you is that these are acceptable values for u. Now let's go back over here. Take 420 and drop it in for u right there. 420, right? I'm taking 420 and I'm putting it right there. Take 420 divided by 2, that's 210. So I'm saying that theta is 210. And 210 is good because it's between 0 and 360. Similarly, take 660. Drop that in for u right there. So 660 divided by 2 is 330. And these were the missing solutions that most students did not have. So it was kind of a technical, slippery little concept where you had to find co-terminal for the values of u because you realized that u was going to get chopped in half to give you back a value of theta. So that was kind of technical. This process could actually become simpler if we used trigonometric identities. And can you guess what we're going to learn in class tomorrow?